Let us discuss about the spectrum. So what is the spectrum? So before that we study about the refraction. You know that when a beam of light which passes from one medium to another, it is going to be deviated from its original path. So that beam of light we are going to call as refracted. Yes, you can see the figure, right? The beam of light which is coming from one medium and which is going to be deviated from the other medium. So right, so that medium is going to be changed here. I mean the ray of light which is going to be deviated its original path, right? You can see that initially it was passing from one medium, right? So after that another medium, when it passes through the another medium, the deviation is going to be slightly changed, right? So that is called, that phenomenon we are going to call as refraction of light. So this is called refraction. When you talk about the spectrum, when a beam of light which passes through a prism, as you can see here, and a beam of light which passes through the prism, which is going to be split up into 7 color of the bands. That color bands we are going to call as the spectrum. This is because the radiation with the shorter wavelength which is going to be deviated from its original path, that will be more than that of the longer wavelength of the radiation. So that's why the red light which is having the higher wavelength which is going to be deviated very least, whereas the violet color, so which is having the shorter wavelength which is going to be deviated more. So that's why we are taking the Weber, because the violet so you know that the Weber, right? So that is 7 color of the bands when it is going to be deviated from the prisms, right? That is called set of color bands we are going to call as a spectrum. So that is called 7 colors, 7 bundles of colors will be there. That is called Weber, starting from violet to red color. So that is violet color, so which is having the shorter wavelength. So that's why which is going to be deviated more from that prism. So what about the red, which is having the higher wavelength, which is going to be deviated very least. So depending upon the nature of the radiations which is going to be emitted or absorbed, we are going to classify this spectrum into 2 types. That is called emission spectra and absorption spectra. So very slight difference will be there, these terms. So that is very easy to understand. What do you mean by emission spectra? Emission spectra, that definition says that radiations which is going to be emitted by a substance that has absorbed energy, right? If you take any substance or atoms, you can take atoms, molecules or ions. What happens? They are going to be excited, right? From ground state to another excited state, they are going to call as, they are going to emit some radiation. That is called emission spectra. So when the atoms, what makes them atoms to excite? What we can do that one? How they are going to excite? If I place this charge simply, it is not going to be excited. When you apply some energy, then it starts moving. So like this. So in order to make the excitation of the atoms or molecules or ions, we must supply the energy. After the supplying of energy, they are going to be start excited, right? So how? By heating or irradiation with some beam of light with a suitable frequency or with wavelength. So that is called emission spectra. So this discuss about the absorption spectra. It is just vice versa. The radiation which is going to be absorbed by a substance on irradiation with the beam of light. So absorption is it is going to take, emission is it is going to give. So that is a difference. So that is called absorption spectra. And the study of either emission spectra or absorption spectra, we are going to call as a term that is called spectroscopy. So spectroscopy is nothing but the study of either this emission spectrum or this absorption spectrum. We are going to call as the spectroscopy. And next, emission spectra, which can be classified into 2 types, that is called continuous spectrum and line spectrum. What do you mean by this continuous spectrum? As you can see that figure. So what it tells that when a beam of light which is passing through the prism, which is going to be divided into 7 colors, that is called 7 different colors, which are going to be ranging from that is violet to red color. So these different colors which are continuously will be there. So that is called continuous spectrum, and these colors they are overlapping with each other. So that is called continuous spectrum. So second one is called line spectrum. As the name indicates, it is a spectrum which consists of the well-defined lines corresponding to some frequencies. So here, when they are going to produce this line spectrum, the vapors of the volatile substance which are going to made to fall on the Bunsen burner flame, So what happens? We are going to analyze this one by using the spectroscopy. So that is called line spectra. So let us discuss about the very important concept that is called line spectrum of the hydrogen. So this is a simple module. So this is called discharge tube, and this is containing the hydrogen gas. I mean, we are going to place the hydrogen gas in this discharge tube. So what happens? These hydrogen gas were subjected to high voltage. So we are applying the high voltage. What happens? Whatever the molecules, which will be available in the discharge tube, that is hydrogen gas, they are going to absorb some energy after applying the high voltage. They want to start the absorption energy. What happens? That molecules will start the breakup into atoms, right? So they are going to be dissociated in terms of the atoms, right? Molecules, when you supply the heat, they are going to release some atoms. The atoms will be break down, right? You know that molecules are always combined with the atoms, right? They are going to split up into forms the atoms. After this, the atoms gets excited. They are going to excited. So at that time they are going to release some energy, that is called excitation energy. And after some times they turn back into their ground state, right? They will emit some energy. That energy of light we are going to call as photon. So at that time the rose colored glow will be appeared in the discharge. So that light which is going to pass through the slits, after passing into the prism, this hydrogen gas will split up into 4 prominent colors. So like this, 4 prominent colors. Like this I am writing here. That is called H alpha, this is H beta, and this is H gamma, and this is H delta. So these prominent lines we are going to call as, this is called series, right? Series is nothing but the number of lines we are going to call as series. So this series which are going to be visible, right? Which is going to be visible for our eyes. That is called, this is a visible region. In the visible region, so set of lines, series which are going to obtain, that is called Balmer series. That is called Balmer series. So these lines of the sets we are going to call as series, and these which are going to only visible for our eyes, that is called Balmer series. Because Balmer series which are going to appear in the visible region, so that's why these 4 lines of the prominent lines we are going to call as the Balmer series. And this Balmer series which exhibits the 4 prominent lines, that is called H alpha, H beta, H gamma, and H delta. So in the different wavelengths will be there. Red color, so it's a respective wavelength, and blue green, it's a respective wavelength, and blue color 434 nanometer, and violet will be the 410.1 nanometer. So like this, in the order we are going to obtain this series. And these series of the Balmer lines which are going to be related with the wave number. So therefore wave number is equal to RH into 1 by n1 square minus 1 by n2 square. So what is this RH? This RH is nothing but the Rydberg's constant. There is a value 106978 something per centimeter will be there. So we are going to make it short, that is 1.09 into 10 raised to 7 per meter. So where here 1 by n1 square and minus 1 by n2 square. So here the value of n2 will be greater than 1. Suppose if the value as n1 as 1, so we are going to take the more values than this n1. So that's why n2 is greater than n1. What happens if I take less values of this one? If I take less value of this n1, the values becomes negative. So this is the Rydberg constant. These are the values, and this 1.09 into 10 raised to 7 per meter. And here what happens? In the Balmer series, the n1 value will be 2. In the Balmer series, the value of n1 will be 2. So when n2 is greater than n1, so what is the value of the n2? So n2 values will be starts from the 3, 4, 5 like this, which are going to be like this. So here in the case of Balmer series, the value of n1 will be 2 and n2 will be more than that 2. It may be 3, 4, 5 like this. So these lines which are going to appear here in this visible region, because you know this big wire, right? So they are nothing but the visible colors. So we are also get the lines in the UV rays as well as the infrared rays. Rydberg generalized the Balmer formula as like this: mu bar is equal to RH, that is 1 by n1 square minus 1 by n2 square. So this, you know this one, Rydberg's constant. So and this is equation is called Rydberg's equation, where n1 will be less than n2. I mean n2 is greater than n1. n2 is greater than n1. If suppose the value of the n1 will be 1 and n2 will be value, it should be more than 1. That is 2, 3, 4 like this will be there. So this is called Rydberg's equation. And we have seen from the experiment of the emission spectra or line spectra of the hydrogen, we have seen the four set of lines which are going to be visible. That is called visible region. So that we are going to call as this Balmer series. So like this, 5 series will be there. So the series simply starts from the number n1 value will be 1, 2, 3, 4, 5 respectively. So that is Riemann series, Balmer series, Paschen series, Bracket series, and P-Fund series. So n1 value will be 1. If you substitute the value of n1, then n2 will be, it starts from 2, 3. So these are called as ultraviolet region. So these lines which are going to be appear in the ultraviolet region. Second one is Balmer series. So this is n1 is equal to 2, then n2 is equal to more than n1. That is called 3 or 4, like this will be start. So that is called visible region. We have seen that colors of that hydrogen lines. So coming to the Paschen series. So this will be starts from the value n1 is equal to 3, n2 will be more than this 3, 4, 5 like this. That is called infrared region. And Bracket series and P-Fund series 4, 5 respectively, and they will be more than n1. So the infrared region. So these will be last 3 series which are going to appear in the infrared region. So let us look at what these are the various transitions of an electron in a hydrogen atom. So like this will be there. So this n1 series you are going to get up with these set of lines. So that is called Riemann series and Balmer series. Also you can see here. So Paschen series, Bracket series, and P-Fund series. These are called spectral lines of the series. These series we are going to call as the spectral lines for the hydrogen atom. So these will be showing the transitions of the electrons in the hydrogen atoms, and these are the respective spectral lines.